Hello everyone, welcome back. So last time we left in part one, we started talking about how to write reaction rates based off a chemical equation or just based off the concentrations and what we discussed. Again, the reaction rate can be written as a change in the concentration of the reactants and the products per unit time. Again, it tells us how fast the reaction occurs. And then today I wanted to go over some other stuff. But first I wanted to discuss those factors that we talked about earlier, the factors that affect reaction rates. So the first one, sorry, let me get the pen out. So the first one was concentration of reactants. So what does that mean? So atoms and molecules must collide in order for a reaction to occur. So as the number of atoms slash molecules increases, the frequency of those collisions also increase, therefore leading to a higher reaction rate. So if our rate, you can say, is proportional to the number of collisions at which they collide, which is directly related to the concentration as well. So the collisions increases the number of concentration, which increases the rate. Another key idea that people don't, or some people need to understand, is physical states. So the physical states determine how easily the reactants mix together. So if there's a greater surface area, the faster the reaction occurs. Again, because there's more collisions, there are more touching. So surface area increases depending on how reactants mix. Sorry, feeling a little under the weather. Next is temperature. So the temperature affects the reaction rate by increasing the number of frequency and the collisions as well. So the frequency is related to the rate, which is directly in relation to the collision frequency, which is then related to the temperature. So as molecules move around, they release kinetic energy as temperature. We can also talk about energy, so which is the rate, collision energy, which is directly proportional to the temperature as well. So, and then last but not least, are catalysts, which we'll talk about, I believe, at the end of this chapter. So, catalysts, we'll talk about in 16.6, but they speed up rates of reactions and they participate in the reaction. They lower the threshold energy, that maximum or minimum energy it needs to reach for the reaction to go. So catalysts you've probably heard in biology like as enzymes and stuff, but we'll talk about those more later. But again, catalysts speed up rates of reactions, and they are part of the reaction. I guess they're participants in the reaction. And one thing you know, you need to lower, or it lowers the threshold frequency. All right. So just wanted to cover those factors that affect reaction rates. Let's talk about expressing reaction rates now. So if we have a normal reaction like we talked about A to B, this kind of review, reactant A goes to product B. So we know that rate for A is going to be the change in concentration of A over the change in time. I'll just leave it as T. Remember, it's negative, which is also can be written as change in the concentration of B over the change in time. This one's positive. Again, because we are consuming our reactant and we're making products. So you can talk about this as the rate of disappearance of A. And then you can talk about B as the rate of appearance of B. Another way, so we talked about this before, right? So another way we can write it if we have a general equation. So maybe if we have coefficients in front of our molecules, so we have our A with a coefficient of W plus X with a coefficient, or sorry, we have B coefficient of X goes to C with a coefficient of Y and D with a coefficient of Z. So we can write the reaction rate and the rate of disappearance or the rate of appearance of the reaction. So we can write it individually as parts. So we have our rate, so we can do our first one. Since these are reactants, these are products, let's write the reactants first. So we can do it as, or set it up as, rate is equal to the reciprocal or the negative 1 over W times the change in the concentration of A over T. All right. So then we can also do the same thing for B. Rate is equal to the negative 1 over the coefficient of B, which is X, change in the concentration of B over T. All right. For C, we do the same thing. This one won't be negative, right? So we have the 1 over W, the coefficient of C, times the change in concentration of C over T, right? Same thing with D. Positive, we have 1 over Z times the change in concentration of D over T. So you can write all these individual parts separately, and we can write it as a whole rate as well. Put them all together. So grab everything you wrote and just write it as a whole equation. We're changing T. Now we're moving to positive, right? 1 over Y. Changing C over T, which is equal to 1 over Z equals, change in concentration of D over change in time. So this is how you would write the whole rate for this specific equation, right? Oh, that's not what I meant to do. This is how you would write the rate law, or not the rate law, the rate for this equation. So then I'm going to do one problem before we go. So an example is, let's say we have 2NOBr gas, which produces 2NO gas plus Br2 gas. So let's write the rate. So the first thing you want to do, I start with the reactants. So we have a negative 1, it's always 1, right? Over coefficient, which is 2, times the concentration, change in concentration of NOBr. This is being difficult. Okay. Over, we know the time, change in T. And we can also write, we don't have any other reactants, so we can move on to the next one. We can write the rate of, let's say, NO. So rate equals 1 over 2, right? We have a coefficient of 2 here, times the concentration of NO over change in T. Perfect. We have one more product, so we have to write the rate for that one as well. The rate is going to be equal to, there's no coefficient, 1 over 1 is just 1, so it's just going to be change in the concentration of Br2 over change in T. So now we can put it all together. So our rate, I'm going to try to write this a little small. It's going to be 1/2 times change in concentration of NOBr over change in T, which is equal to the 1/2 times the change in concentration of NO over change in T times the change in concentration of Br2 over change in T. And this is the whole rate equation. Some things to be mindful of when you're writing these equations is don't forget the negatives. So make sure you check back and look at your work. Make sure all the reactants that you wrote are written there, that you have a negative in front of them, and all the products are positive. Because the sign error is going to give you a wrong number. And you'll see in the next videos that we're going to be working with actual numbers, and we're going to be working with questions that give you information on how to solve these. These videos are just to help you to how to set up a rate law, not a rate law, I keep saying rate law, I apologize, a rate for a specific equation, and make sure we're doing the 1 over the number, depending on what the question is asking. Later, they're going to give us information about like maybe the concentration or the time or the ratios. But yeah, this is just how you would write a rate expression. And then the next coming videos, we're just going to do a couple practice problems. But yeah, I'll see you in the next one. And also, before I go, leave comments if you have any questions or if these videos make sense. Any feedback is helpful. But again, thank you. We'll see you soon.